All right, ladies and gentlemen, today we're going to be talking about the Hatboard and how this thing's put together, and a couple of things that you need to look for when you're going to assemble your Hatboard. But before that, we're going to talk a little bit about just some basic soldering tips. That way you can get the best result when putting together your Hatboard for your Raspberry Pi. So one thing to do that's good before you begin any soldering project is to make sure the tip of your iron's in good shape. This can be accomplished a couple of ways, but one of the easiest ways to get your soldering tip in good working shape is to take a small piece of sandpaper. 120 grit sandpaper works pretty well, and just rub the tip of your iron around there and just make sure it's nice and clean. That way solder will flow a little bit more freely once your iron's hot. Sometimes if your iron's in really rough shape, you can use a flat file to clean or to shape your tip. This should only be used in extreme conditions when the tip of your iron's really not working well, and things such as tip tinner or sandpaper just aren't doing the trick anymore. So when you're soldering anything, there's a couple of things that you're always going to find. Number one, there's going to be a component leg or a pin, and there's going to be a contact point to which we are going to solder. That solder should make essentially a nice connection from this contact point, and we'll talk about this later, but what we're going to be looking for is this nice Hershey kiss shape from contact point to component leg, but we'll get to that here in a minute. Also, you're going to obviously need some solder. Get yourself a nice, good piece. I would strongly recommend, making sure it's long enough so that you don't have to hold the solder really close to where you're working. Once a piece of solder gets too short, sometimes it's really easy to burn your fingers if you're holding that solder in close next to where the work is being done. And then obviously you're going to need a soldering iron. This is what allows us to make the connection between the contact point and component leg. So once you've gotten your tip of your iron sanded or filed and it's nice and clean and ready to work, you're then going to have to take your soldering iron and allow it to heat up for one, and assuming the tip of your iron's nice and clean and ready to work, you're going to want to go ahead and tin the tip of the iron. Now, essentially what this does is it puts a little bit of solder on your iron, and when you go to make your connections, it's going to allow solder to flow freely from the tip and allows better heat transfer to your circuit board. You can tin the tip of the iron with solder as soon as it's hot enough to melt the solder, and this is a good way to essentially check to see if you're ready to start working. If your soldering iron's not melting the solder before you go and try and make a connection when you go and tin the tip, then you either need to clean your iron a little bit better, or you're going to have to wait a little bit longer for your iron to heat up. Another way to get the best possible results with any soldering project is to make sure you're cleaning the tip of the iron frequently using a damp sponge. Now, you really don't want your sponge soaking wet, but get it damp, and by rolling the tip of your iron on the sponge, that allows you to clean it and keep it working as good as it possibly can. So the objective when you're soldering a project is to create what we call a wedge between the pin, the component leg, the wire lead, and the copper pad or contact point you're trying to solder. And this is going to involve you to touch the solder to the copper pad so that the heat will melt the solder around the lead and form a bond that looks similar to a Hershey kiss. And we have a graphic of this on the next slide. And essentially what that means is you're going to want to take the tip of the iron and touch it to both the component leg and the contact point, and that's going to form a little wedge on one side of the component leg. And then from the other side, you're going to take your solder and you're going to touch it to the other side of the component leg and the contact point. Solder should be touching the opposite side of the component leg. And what that's going to do is draw the solder around that component leg in order to form this little Hershey kiss shape that we often refer to when soldering. So if your iron's nice and clean and you create the wedge that we're talking about and solder is able to flow freely, you should get this Hershey kiss shape of solder that should really only be on the component leg and the contact point. And if you have solder that's, touching another contact point that may be, say, over here, that's going to be a bridge, and that's really not what you're going to want to have. That'll actually create a problem with your board. But essentially, this little Hershey kiss shape is what we're looking for. And if we take an actual look at a board, here you see an example of what that Hershey kiss shape looks like in the real world when we go and have a proper solder connection. So here we see two different pictures of essentially the same connection. Up here at the top we see that we have solder only touching this contact point and only touching this contact point. And then down here we have what's affectionately known as a solder bridge. And this is when excess solder has connected pins or component legs together that shouldn't be. And this is going to create problems in your circuit. So be very, very careful of this, especially with our hat board that we're going to be soldering here in a little bit. There's a lot of difficult solder connections on here because we're soldering in header pins. And you really need to be aware of whether or not you've maybe accidentally connected those pins with solder. Another thing you need to be aware of before we start talking about the hat board specifically is just making sure you keep your cord free from the actual soldering iron. It's very, very easy to melt the actual cord of your soldering iron, and this can occur unintentionally when you go and place your soldering iron back in the soldering stand and that cord touches the holster for the iron or the and what it'll do is it'll melt the wire. It's not good. Okay, so when we're looking at all the parts that come in our hat board packages, we should find three different components. We should find a row of female header pins, and that's these here. We should also find 4 sets of regular 3-pin header pins, and these need to get soldered in. These are what we'll eventually connect our servers up to. And then you should find a 2-pin power terminal somewhere in that package. The rest of the hat board components are already assembled, and that should include a barrel jack connector, which is here. You should also have voltage regulators and a couple other surface mount components already on your hat board. The only things that we need to solder on are here for this project. Before anyone begins soldering, I do want to point your attention out to a couple of things about the hat board, and most importantly is the orientation of some of these components. You need to realize right now that your female header pins go on the underside or the bottom of your hat board, and the solder connections are actually made on top. With your other components, your 2-pin power terminal and your regular header pins, they go on top of your hat board, and your solder joints or solder connections are made on the bottom of the board. If you place these incorrectly and you solder in your female header pins so that they're oriented on this side of the board and you make your solder connections here, your Hatboard will be useless. You will not be able to connect it to your Raspberry Pi because it's going to prevent you from plugging in servos into the header pins you see over here, and it's going to render it useless. So be very, very careful that you understand the orientation of these components. Again, the female header pins go on the underside of the board, and the solder connections are made on top of the board. This is going to allow you to plug into the GPIO pins on your Raspberry Pi. The rest of the components, the 2-pin power block, go on top of the board, and the solder connections are made on the bottom of the board. So here we have a look at the header pins, how they're soldered into the board, and the underside, and what those soldered joints should look like. You need to take notice of a couple of things. One, the length of either side of these pins. Now, save yourself the headache and make sure you're soldering the shorter side of that pin into your board. This is going to allow you enough of the pin to plug your servo motors into once you're done. Now, the other thing that I want to point your guys' attention to has to do with the bottom of these boards and making sure we're not creating any solder bridges between these rows of pins. There should not be solder touching each of these individual contact points. These should be completely separate. If they're not, let's say you have solder touching both of these points, you're going to create a bridge, and that's not what we want. Same thing if you had solder going horizontally. This can cause damage to your servo motors and other parts of your project as well. We really need to avoid solder bridges here. Here we see the female header pins soldered into the top of the Hatboard. Notice where these solder connections are in relationship to the barrel jack power connector and your 2-pin power terminal over here. This is different than where you're going to be soldering the rest of the connections. And again, be mindful of solder bridges. We don't want to connect any of these contact points together with solder and create a bridge, because that'll cause problems for us down the road. But the solder takes place on top of the Hatboard here, and that's going to allow you to mount your Hatboard onto your Raspberry Pi with the correct pin assignment.